Hi guys, it's Dr. Justin Southey here, going through semester test 2. I'm looking at question 13, where you're asked to find dy dx if x over y is equal to x plus sine of y. Now most of you did quite well on this question and recognized that it was an implicit differentiation. Some of you tried to solve for y. Well, you can't do that because this y is implicitly tied up in this sine, so you can't get the y out on its own. Also, some of you tried to take the log of both sides and then do some logarithmic differentiation, but it's actually quite a little bit easier than that. You simply have to differentiate both sides and then solve for y prime. So we're going to differentiate the left-hand side. Now we've got a quotient, we've got x over y, so we're going to use our quotient rule, which says that you differentiate the numerator. Derivative of x is simply 1, and multiplied by the denominator untouched, so that's times y, minus the numerator untouched, so that's going to be x, multiplied by the derivative of the denominator. In this case, the denominator is y, so its derivative is y prime, or if you prefer, dy dx. I prefer y prime just because it's a little bit shorter, but of course these are exactly the same thing, it's just notation. And we're not quite done here. We're differentiating a quotient, so we need to divide by the denominator squared. So derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. That's the derivative of the left-hand side. And now we differentiate the right-hand side. Derivative of x, well, that's simply 1 again, plus, and now we're differentiating sine of y. Now, of course, remember that y is a function of x. So this is the sine of a function of x, so we need to use the chain rule. Outer function is sine, so the derivative of sine is cos. Leave the inner function y untouched, and then multiply by the derivative of the inner function. The inner function is just y, and its derivative is dy dx, or y prime. Right. So we've done the derivative of the left-hand side, derivative of the right-hand side implicitly. We now need to simply solve for y prime. It gets a little bit complicated because we've got a y prime on this side, which is involved in a fraction. So let's get it out of the fraction. Here we've got y over y squared, so that's going to be 1 over y, minus, and this guy over here, which is x times y prime all over y squared, and that's still equal to 1 plus cos of y times y prime. Okay, we want to get the y prime terms on their own on one side, so let's do that on the left. So we've got minus x y prime all over y squared. Let's get this term across to that side, so that becomes minus cos of y times y prime, and that's now equal to 1 minus, we're going to take this thing across to that side, 1 over y. We want to solve for y prime, so we're going to take out a factor of y prime. That goes into x over y squared minus cos of y. And that's equal to still 1 minus 1 over y. Okay, the last step now is simply to divide both sides by this big thing over here so that we get y prime on its own. So we end up with y prime is equal to 1 minus 1 over y all over minus x over y squared minus cos of y. And now we found the dy dx, or we found y prime. Of course, this is a little bit ugly. We can simplify it a little bit. We've got here a fraction inside a fraction and this fraction inside a fraction. Both of them are divided by something of y, so maybe we can cancel those y's if we do a little bit more work. Let's see if we can. We rewrite this 1 minus 1 over y as y minus 1 over y. Okay, common factor. And all of that is divided by, again, let's rewrite this as one thing over here. So we write it over the lowest common denominator of y squared. So that's minus x minus, we need to introduce a y squared cos y all over y squared. And if you do your fraction work carefully, you know that divided by this fraction is the same as multiplying by its reciprocal. So this is going to go into the numerator. This becomes the denominator. So we get y minus 1 y squared all over y times minus x minus y squared cos y. And now, of course, we can cancel this y with one of those, this y here with one of those y's there. And what else I'm going to do is I'm going to multiply through by minus 1 over minus 1 to get rid of these minuses in the bottom. So when I multiply y minus 1 by minus 1, I get 1 minus y. And we're going to be left with only one y there because we cancelled with that one there. This y disappears, and of course we multiply through by minus 1 over minus 1, so this becomes x plus y squared over cos y. And that's just a slightly nicer way of writing it than this one over here. But the majority of the work is in the implicit differentiation, solving for y prime, and then getting y prime all on its own. But of course we like to write things in as nice a way as possible.